Greetings, math students. Today we're going to be talking about Pythagoras' theorem. Pythagoras' theorem. Let's get right into it. So the theory of Pythagoras, who was a really smart mathematician over 2,000 years ago, he's also Greek, he discovered something about triangles. And he said when a triangle has a right angle, we know that as right angle triangles, and we find the squares on each side of that right angle triangle. As you can see here, the square on the hypotenuse is red. That's the same thing as squaring the length of the hypotenuse, right? And then squaring the length of the other side. When we do that, as you can see in the green and the purple area, it says that the biggest square has the same exact area as the other two squares put together. So this red square has the same area as adding the green square and the purple square together. Yeah, and that is what is called Pythagoras' theorem. That's the principle behind it. And we can show that equation in this way. We can say that a squared, if a is the length of this side right here, we say a squared is equal to b squared. There we go. B being the length of this side. A squared plus b squared would be equal to our c squared, which is the square on our hypotenuse. All right. So this is the official definition. It says that the longest side of the triangle is called the hypotenuse, as we know. So the formal definition is, in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides, as in what we just explored. So we'll go through an example. You can pause this video, you can go back and watch it again. But this is the principle that we are discussing today. All right, so let's imagine that we have our triangle right here, and we have one side being 3 centimeters and the other side being 4 centimeters. And we're now told, right, we're now told to find x, which in this case is our hypotenuse. So what I would normally do is to label my triangle. We don't have to, but it helps us to identify the different parts. So I go A, B, C. And it doesn't matter what you call each side of the triangle. You just have to stick to the principle of Pythagoras' theorem, which is always the square on the hypotenuse. So we look carefully at this triangle, and we see that our right angle is at B. Therefore, the side that is across from B, from angle B, must be side B, right? Which is our hypotenuse in this case. We look at angle A, sorry, and we see that the side across from angle A must be side A. And of course, the side across from angle C must be side C. So this is C. So remember what Pythagoras' theorem says. It's always the square on the hypotenuse. Let's go. In a right angle triangle, the square on the hypotenuse, right, is equal to the sum of the squares of the other two sides. So we can start with the square of the hypotenuse, right? I like to write it that way. That the square on the hypotenuse, which in this case is b, so we have b squared being equal to the square on the other two sides. So it's b squared is equal to a squared plus c squared, right? And now I fill in the information that I know. I know my b squared represents what I'm trying to find, which is my x squared, and that is equal to a squared. In this case, a is 4, so that's 4 squared plus c squared, and in this case, c is 3, so that's 3 squared, right? Now I want to find what x is, right? I already have x squared on one side, so I just work out the numbers on my right-hand side to find out what x squared is, then I will solve for what x is equal to. All right, let's do it. So x squared is going to be equal to 4 squared, which is 4 times 4, which we know is 16, plus 3 times 3, which we know is 9. Therefore, x squared is equal to 16 plus 9, and 16 plus 9, as we also know, is 25. So far, so good. Now we want to find out what is x. We have x squared, and we need x. So what we're going to do, we're going to find the square root of both sides to find out what x is, to get rid of this square right here. So it's the square root of x squared and the square root of 25. Square root of x squared is just x, and the square root of 25 is 5. We put back our units as centimeters. And there we have it, our answer. Our answer for the hypotenuse in this triangle using Pythagoras' theorem, we have found to be 5 centimeters, right? So we used Pythagoras' theorem. All right, let's do a second example. Let's imagine that we have this triangle right here, where in this case, we already know what the hypotenuse is. We already have our hypotenuse, and we're trying to find another side over here, right? So let me label this triangle as well. So I'll call this triangle let me call it something different. Triangle DEF, because we can use any letter, right? But we just stick to the principle of Pythagoras' theorem. Now, if this is triangle DEF, we know that the sides opposite each angle, will be called by that letter name that is on the angle, just in the lower case. So we have angle E at the right angle. So we know that the side across from the right angle is our hypotenuse, and it would be called side E, and that's common E. Same thing for the rest of the sides. If this is F, then the side across from F, which would be our 12 in this case, would be side F. That's common F. And finally, the side across from D, or angle D, would be our common D, which is what x is equal to. So again, using Pythagoras' theorem, we are going to set this out to find our x, to find our unknown. So we will say E, which is our hypotenuse, E squared is going to be equal to F squared, or we can start with D squared plus F squared, seeing that D comes before F in our alphabet, right? So E squared is equal to D squared plus F squared. It doesn't matter which one we write first because it's addition. And, you know, the order of addition, if we're adding two numbers, it doesn't matter because addition is commutative, right? So if I'm saying, for example, just a side point, if I'm saying 1 plus 2, which is 3, is the same thing as saying 2 plus 1, which is also 3, right? So we say that addition is commutative. So that's a side point. All right. So let's get back into our let's get back into our Pythagoras' theorem. So we've written out what our Pythagoras' theorem will look like in this example. And now we are going to fill in the information that we know to find the information that we want. So we know that E, excuse me, is our hypotenuse. So E is our hypotenuse, which is 13 in this case. So it's going to be 13 squared that's equal to d squared. D in this case is x, so we'll say x squared plus or 12 squared, which what f is equal to, or 12 squared. So we'll continue. We'll go ahead and work this out. So 13 squared we know is 13 times 13, which is 169, which is equal to x squared plus 12 times 12, that is what 12 squared is, which is 144. Now, I want my x by itself. That's how I will solve x. So I need to get rid of this 14. So what I'm going to do is to subtract, not this 14, this 144. I need to get rid of this 144. So what I'll do is I'll subtract 144 on this side to get rid of it. So it's x squared plus 144 minus 144. But we remember the principle. The principle we apply here is that whatever we do on one side of an equation, we have to do on the other side to keep it equal. So since I subtracted 144 on my right-hand side, that cancels each other, I also need to subtract 144 on my left-hand side to keep my equation balanced. So while 144 from 144 will leave me with x squared, right? Because 144 minus 144 is 0, and I have the x squared on that side, so I just write back my x squared. I know that 169 minus 144 will leave me with 25. That leaves me with 25. Now I have 25 is equal to x squared, but I still need to find my x. So what we do is to find the square root of both sides to get rid of the square on the x, right? And we know that to find the square root of 25, we plug that into our calculator. If we don't already know, is going to end us up at x being equal to 5. And the unit we write back here is centimeters. So these are two examples that we do in Pythagoras' theorem, and I hope you have a greater understanding of the concept